In this video, we shall estimate using the method of moment for the geometric distribution. For more on this topic, you need to subscribe to this channel. Solution. We should note that for the geometric distribution, x follows a geometric distribution of 1 all over p. It then means that the expected value of x is equal to 1 all over p. And for the method of moment, the solution to the method of moment gives you the population mean must be equal to the sample mean. When you have this, you have the solution of the method of moment. So, for the first moment, since we are estimating just one parameter, for the first moment, we have that mu is equal to the expected value of x. That means the population mean. And the expected value of x is equal to 1 all over p. 1 all over p. We take this as our equation 1. Also, the sample mean is given as 1 all over n summation of xi, as I running from 1 to n. And we know that this is equal to x bar. We take this as our equation 2. The next thing to do to get the solution or to get the estimates of p, we combine equation 1 and equation 2 to give us something like this. So we write combining equation 1 and equation 2, we get 1 all over p to be equal to x bar. It then means that our p estimate is equal to 1 all over x bar, meaning p is biased. So our p estimate for the method of moment for geometric distribution is equal to 1 all over x bar, which is the mean, or you can call it the sample mean. So this is how we can obtain the method of moment for the geometric distribution. For more on this topic, you need to subscribe to this channel.